we have this parse ops thing. It takes a list of string, should return a maybe event type. In this instance, I think it, yeah, since the CLI is so simple, you can like you can just like use pattern matching like this to deconstruct this list. Return nothing in this case. Hello. And in this case, it's just upgrade, and in this case, it's just downgrade. And yeah, that should. If you just give it anything, or just do stuff like this, it will print the usage. But yeah, oh, this is hitting our previous validation. So we built that. This will what's going on? Oh. So this will print usage. This should print the show instance for event type, which is upgrade, and down also works. And then based on that, you can do whatever. So that's like a minimal way of doing a CLI. And you could also here do some other deconstruction and see, like for example, if you want to know whether whether the user wants to run all migrations or just downgrade or upgrade a single revision, you can read whatever like here. And this kind of thing works pretty well if your CLI is very simple and you don't want the overhead of going full, like using a big library for this. Like if you have 2 commands and simple arguments, I recommend you just use this because like it's just going to work. But if you want flags and multiple options and subcommands and non-trivial like parsers and auto-generated docs and a bunch of error messages, there's this one package which I can recommend you look into. It's called opparse applicative. I won't discuss most of it. I won't get to this today, I think, because I want to do attoparsec with you. But in general, this is a bit of a parser thing, and you can build options in a certain way. And if you build options in a sort of way, then you can make this library do this kind of logic for you, but then things are accepted in a certain order by default, and it's all pretty nice. So if you want more, and you want more control, and you don't want a bunch of boilerplate or error-prone handling of interleaving, that kind of stuff, then I recommend you look into this library. There's also something that this library tends to get boilerplate-y if you use it, but it's so there's also this thing which I might as well also point you to, options generic, I believe, opparse generic, yeah, which is a way, it also uses opparse applicative under the hood, but then it can automatically derive the implementation for you. I only recommend you look into this one when you first understand this one. That's like the order of doing things if you ever want to do this. So this should give you like a simple CLI, and then you have an event type. Basically, right, we have an event type. You kind of need to change this function then to also accept the event type. Oh, we're not using it yet. This is annoying. Oh yeah, and we also need to pass that in there. And that should give you like the structure you need in order to do this kind of logic. But if you do this kind of logic just in this function for downgrades, like which migrations to run and that kind of stuff, things will get a bit more complicated, so I'll give you another hint. One of the things you are probably going to want is do this. Because when you downgrade something, you want to have in run migration, like right here, there's this call to mark active revision, and you're going to need the information. If you're running a downgrade for a migration, you got to know what the migration was that came before it. So you need the, I call that a parent. And then you don't need to change this signature much. And you don't need to give this signature and this function, make it more complicated where you do the looping yourself. You can still keep using form. First of all, do people understand the problem that I'm trying to solve with the parent stuff? Getting a bit of stares. Do you want me to go over it a bit more? I'll go over it a bit more. Like there's this list, right, of stuff we need to do in a particular order. And then the user says, I want to downgrade one revision. What do? We get the current revision from the database. We can filter migrations, our list of migrations, so that we don't get this part of the list, but we get this part of the list. Like, that's fine. And that's pretty good. But when we go over, and we need to reverse that, first of all. But when we go over that and do a downgrade for each of those migrations, we need to know what new revision to record in the database. And it's not the revision of the current migration we have access to in this function. It's the migration which came before the migration in like the original file, so the parent. And that needs to be the revision which we store in the database after we run a downgrade. So that's why you're going to need that bit of information. This is for when you implement downgrades. I recommend to do that. I won't. I feel like we can also implement downgrades, but let's just see how far we get today. That's my pieces of advice with data types and with information you're going to need and with bugs you're going to kind of run into. Let's see if you can. If I were you, I'd just currently, because in the interest of time, record this kind of information in your data type, and then we'll see how we can parse the actual config file in a bit. I'll talk a bit about AutoParsec.
Can I ask a more Postgresy question?
Yeah, sure.
Is there a way to, for a subroutine like a helper function that you're running inside a transaction to constrain it to only being inside a transaction, it feels dangerous to have I/O there and basically just say, hey, you're doing whatever. Just thinking in terms of long-term maintenance, someone else could reuse that function and not realize they need to be within a transaction at all. Is there another monad or anything that you could do to kind of compile type, check that sort of thing?
So if I understand the question correctly, you want to be able to, if you have a function.
Let's say I have a transaction that wants to use helper functions A, B, and C, and they're each
Yeah.
executing something in SQL.
Yeah.
How do you make sure that someone doesn't just take B and run it off somewhere by itself and introduce some kind of issue there, consistency-wise?
Yeah, there are a couple of ways you can do that. One of the things which is...
Or like execute taking a transaction instead of a connection or something.
Yeah, connection isn't a data type in this library, and transaction isn't a data type in this library, as far as I know. You could indeed do a new type over connection, where you ensure that it's in a transaction. That could work.
That's fun.
And then you can only have transaction values passed into a function. That could be the case. Sometimes you want to do another thing where you don't want to be able to do arbitrary I/O inside while you have a connection and a database transaction open. That's like the reverse thing. So if you are in a position like that, then you're probably want to define your own monad kind of thing and define a few functions which you can use in there.
It's kind of a long-term maintenance issue I've run into in other languages as well. So I thought it was interesting to think about how Haskell could help you out of it.
Yeah. Yeah, you could do a new type if you want.
Nice.
That's actually a pretty good one. I'll write it down for the next time I do this.
Like in dynamically typed languages, the best practice is don't split that stuff into helper functions because you're never going to be able to stop it. So just keep everything in the same gigantic routine for your transaction. Not pretty.
Right. All right, so I also want to take a bit of time to talk about this library. This is called Parsec, and it's a parser combinator library. And if you've never heard of that term, then it may sound scary. But it basically, the goal of this library is to help you write parsers, which are efficient and pretty correct, and a joy to write. And a parser is something which takes input and then in a sort of unstructured way or without a data type and returns a value of a data type which is extracted from there. So this is happening when you are dealing with JSON, for example. If you're doing JSON, you get like just bytes, and then those need to be interpreted as UTF-8. But then also the string, right, has a certain structure with curly braces and a bunch of other things. And implementing something which goes from that string to like an actual data type is called parsing. And Parsec is one that I picked because, yeah, there's a couple of ones. I'm not an expert on parsing libraries. I know how to use this one, and they all have the same sort of interface. Doesn't really matter which one you pick, in my experience, except that there's one thing which is called backtracking behavior, which is important. Forget about that. So if you have like this thing, Parsec, it has a library. It is a library. It has a bunch of modules. You're going to need this one: data, Parsec, byte strings, char8. And it has a parser type. And parser is something internal to this library. It's your main interface in which you will do things with Parsec. You create and define parsers, and you combine them. And in doing so, you can you can build a computation which efficiently or in a cool way accepts or rejects input. And these people give you a bunch of things about error messages and a bunch of other things. So I just want to sort of show you how this kind of thing works. So we can import data Parsec byte string char8 as a. Does it work? Oh, whoops. Am I in the correct place? Yes, I am. So when you do this, this library has a function parse, and it runs a parser. So it takes something of this parser type, a byte string, and then returns a result. It also supports incremental parsing, which is pretty nice. It's a cool feature. And it also has this parse only function, which you probably want. It takes a parser, a byte string, and then either gives you a string with an error message or the value that you really are interested in. Well, so how does that work? You can do something like this again, where you do this kind of either pattern and print the string and exit and that kind of stuff. But then the question is, like, how do you get a parser? What does a parser mean? So one of the things you can do is like click on this link here, because parser from this module is a type alias for parser from this internal module. And then it says this is the core parser type. You think this might not be too important, this bit of what the type an instance is, but it's very important because it's the core of how you use parsers and how you use these kind of types. So instead of babbling on about that, let's like do index file p is a parser of a list of migrations. Oh, whoops. And it's not a list of migrations, it's a list of migration. And it's complaining about, oh yeah, I added this, this parent field, but I'm not initializing it here. Quickly make it stop complaining. And if you have a thing like this, you can sort of run it. So right here, we oh yeah, we want this all migrations thing. We're going to change that into a dot. Let me hop back here. Dot parse only. Index file contents with the index file parser. Is byte string dot read file. Like read our actual index. Oh, this is not byte string. This is yes. And then this is probably complaining about something. It's complaining that this is an either string migration and the expected type is an IO migration, and we've seen this problem a bunch of times already. So we're going to use our little pattern here. Either exit die pure and just prefix this, right? Now we get some type checking. So how do you do a parser with parsec, or with addo parsec, basically? Well, if you take a look at this module, you'll see all these kinds of small functions. And you can give them things, and they give you values of the parser type. So for example, char will take a char, and it will give you a parser for the type char. So that's something we can use in a larger structure to parse individual characters. There's also any char, which matches any character, not char, a bunch else. The idea is that you combine these functions, which are called combinators, which is why this is called a parsing combinator library, in order to get some bigger, interesting values, right? So one of the things, like let's read like this index file. It contains 3 lines, and we want to be able to get migration, a migration value out of each of these lines. So what we want to do is this part is going to be the rev. This is going to be the description, and m file is going to be like this entire thing, right? That's what we want to do. So if there's unstructured information in some unknown format, and we need to tell our thing to actually be able to read the structure. Does everyone understand the problem that we're trying to solve? Is everyone okay with like this parser type, and that it might help us solve this problem? I'm going to show you how to use it. So I previously mentioned that parser is this monad, right? So pure is a thing. Pure takes a value, lifts it into a context. Here we take an empty list, and we get something which like initially type checks, which is not undefined, which can be pretty nice. But like an empty list of migrations is not a very very useful value. So let's do something more interesting, and we can sort of defer the problem a bit. Like let's say we want to parse a single migration, like make the problem smaller, right? Migration P. Now we have. Let's also make this type check for a bit. And yeah, that should work. Well, our index, remember, is just a list of these individual migrations. So is there anything which is operating on lists? This looks a bit promising, right? Many1. It applies an action over one or more times, and it returns a list of the return values of P. So, well, if we, sorry, is this the right module? Many1. Yeah. So this function many1 will take an alternative, and this parser is also an instance of alternative. Just believe me for a bit. So we can do something like this: many1 migration P, and these are our migrations. And this type checks. So we have like this. So we've deferred the problem a bit because we still haven't done anything with actual values, but the structure is clear. That you have like this combinator from this weird many1 thing, and it takes this other weird parser thing, and then that magically makes it like turn things into a list. That's pretty cool. But yeah, this one is not very good yet. But let's at least get started with some things that might be in here. The structure is already here. We want a revision, we want a description, we want a parent, but we don't have enough information for this yet. And we want like a base file. And this parser is intended to parse a single line of things. And what do single lines of things end with? They end with a new line character. So let's see how we parse an actual character first. Start at the back. So a.char, then we can do something like this. And that also still type checks. So this does not accept anything yet. Currently, this will return, like, if you run this, what kind of file would this parser actually accept currently? Let's see if you sort of get it. Think about it for a bit. It will accept files which only contain new lines, and for every new line, it will, in the file, it will return this same migration here. That's what's actually happening. And this file needs to contain at least one new line because that's what many1 requires. It just enforces that there is at least one. All right. Well, if we want to see and I'm just going to program this out because I think it might be nice if you have never seen this before to see like someone work for an example. So let's see. Let's try to get. We're on this one line, and let's see if we can get only this and read it. What does our structure sort of tell us? Well, there's this underscore that we can maybe use. And if you've used parsing combinator libraries, then there's something which is called tail, which you just know about because you learn all these magic combinators after a certain point. But here I'm just going to tell you, don't worry about it. There's this many till thing. Actually, sorry. Real quick. Oh, damn it. I was wondering. Yes. Thank you. Different function. There's this take while thing, which you just know about, and which you can use. And it's also from the same module. So there is this a.take while thing, and it accepts a predicate, which takes a character and should return a Boolean value. So if the character is not equal to an underscore, we want all the stuff. So that gives us a revision. Or it gives us the byte string for the revision. So this is something we cannot do currently, rev. We need rev. Another thing, we could also have solved this in another way. If we wanted rev, like this rev with a lowercase, so actually have the type rev, how would you go about doing that? Remember, we're using do notation, and Haskell has all these standard type classes for doing things. Which type class allows you to take values in a certain context and change their type? Yes, fmap. The parser is a monad. Parser is also a functor. And like this is special syntax for fmap. This type of operator. We could have also written this. But like this kind of notation, if you're using these kind of libraries, it is extremely common. So I'm just going to use this infix version of fmap and tell you to get used to it. So I have this rev, right? And I just showed this off. But to be honest, right here, it's not the best of ideas because we will also need this bit of information to construct this base file value in a bit. So changing the type of this lowercase rev is not going to get us in a bunch of in any places because we just need to unwrap it here. Cool. So we have a rev. We have something which is not an underscore. Then we want the actual underscore. And then we accept everything until we reach a period. We accept, this is the description. We accept everything until we reach a period. Then we want a very particular string, so we can write string, I believe. Yes. and one SQL. And this is like the extension. So we have a rev, we have a description, and we have a new line. And this bit is how you define a single line using parser combinators and get some information out of it. And it's pretty nice. Like, notice that we're not trying anything or doing regexes or yeah, we could even do if statements right here. It's pretty crazy. This is so very nice if you're parsing kind of any unstructured information that I just had to put it in here. Like if you can do this properly and if you know how this works and are a bit fluent in it, it is an actual superpower, and it happens so often that you need this, especially if you're doing boring stuff and like taking stuff from other commands and just standard out and want some resemblance of structure and reason about it and don't want to use grep. This kind of stuff is really cool. Yeah, so this is how you do parsers and how you use their applicative and monadic and whatever features of these data types. So this will now we still actually need to use this like description and rev. We already used the rev here. Description is description. The parent we're not gonna worry about just yet. And I'm also not going to worry about like this DB thing. Just going to hard code it for now. I can show you how to change that if you want later. The 002 should be our rev. This should be like this underscore. Then we want the description, and then we want .SQL. Right, and M base file is a file path, so we need bs.unpack to turn it into a string. So this is overloaded strings byte string, basically, this DB literal. So byte string, byte string, byte string, byte string, byte string, and this operator is like concatenation, right? It's from Monoid. Yeah, so that's our migration parser thing. I guess it should maybe, hopefully, kind of work. Let's comment this. We don't know because we haven't written a test, so Sid is has an opinion about this. Let's see if we can print it. Oh yeah, and we, a thing we did do was like properly annotate this, call this, actually read the index file, right? We did this. So we actually get some migrations right here. This is the actual, and to show you that I'm not lying, let's edit the index file and remove this. For example, only contain bootstrap. Whoops, up. Now, this list is only containing one thing. So, are you reasonably convinced that the parsing code that we wrote is actually parsing things? That's very nice. So, this kind of thing is like an amazing superpower to me, and I use and abuse it all the time, even though sometimes you arguably maybe shouldn't. Right, so one of the nice things about this is that it also makes it reasonably easy to like get extra information in here. Like for example, if we want to have this migration parser thing, how would you, when you're here, like in this thing, know what to put on parent? We kind of want to know this. And we want to know it ideally as soon as possible because we don't want too much values of a type where we haven't really initialized it correctly. So one of the things you can do is just give this does this actually work? That's a good question. Oh yeah. You can also these parents. Also these parsers, like any other function which is operating in a context, like I/O and stuff, they can also just accept arguments, and you can also use them in the body of the parser, right? This is not any different than having a function return an I/O value based on pure values, right? And using this in the definition of that. The parser itself is currently not doing any I/O. The monadic thing here is the control flow. But like adding, it took me a while to like realize that you can just add function arguments to these. So I'm just telling you now, so you don't spend a bunch of time thinking, oh, how do I do this? So in a similar fashion, we could also base dir argument, do this, right? And then blah, 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 blah. And then we change this into the base dir. Make this configurable. Then we, oh yeah, this is like slightly ugly because we then need this and that doesn't work. Maybe it does work. And then this index file P needs like this this argument, right? Barons. So that's sort of how you pass in values. One of the things when I originally wrote this one was do something like this. So you can also like mutate or not mutate, process stuff like in a parser. That's not a problem as long as you use pure. It's pretty cool. And then here, if you really want to write this, it's a bit hairy, but there's this this function in data list which is called map QML. That like takes an initial value, a traversable or list of things, a function which gets the initial value and an element of this list and returns a tuple, and A is state. So you can use this to, yeah, it's like a combination between fmap and fold. It says it right here. You can use this if you want to traverse this list of if you want to go through this list of migrations and set the parent for each of the migrations except the first one, which does not have a parent, which uses nothing as a parent, right? So you want to do something like a map, a QML list, I believe, our random function, migrations, nothing migrations. and then that returns the tuple with state. We don't care about the state. So this is our structure. Map QML, no. Data.list. So yeah, right now it's complaining about the type tool, and we need to implement this, like maybe A, get a migration, return a maybe A tuple with migration, and we can pretty easily do that because like here's the parent, which is the maybe A. Oh, it's the lambda. Parent, migration. On the migration, so we need to return mrev migration and a migration which has this parent where parent is, let's see, the parent, yes, and mrev migration is actually incorrect. It needs to be just mrev migration. And does this, like, will this work? Okay, I'm very pleased with myself at this point. So this is like an unreadable one-liner, right? But you can imagine like extracting this this whole thing in its own let. So set parents. So we have something like this. I hope this still works. It still works. We're out of time, I see. Yes. So I'm going to close. So I hope this last bit has been kind of interesting and informing about what you can do using control flow, and what you can do using these kind of parser things, and what you can do maybe even like some wizardry with higher level functions like this, right? Thank you for coming. I hope this has been insightful and instructive in like getting actual code to run and writing some code which talks to a database and maybe is not necessarily purely a mathematical exercise. I hope that you liked this. Thank you so much for coming and for all the good questions. I'm sad to say I won't be around here for much longer because I need to get a flight. But if you need me, you can go to this website and then click here. And then you see my email address and send me whatever if you want to get in touch. Stuff will be on GitHub. I will post this implementation and maybe like the other one I have in another repo. Like soon-ish, like when, like, and I'd very much appreciate any feedback you might have on this. You can also send it here. If you're worried that you upset me with your feedback, then use a throwaway email address, please. But I'm pretty friendly. Thank you so much for coming.